Welcome to installment 18 of writing a 6502 assembler in assembly language. In the last installment, the symbol table routines were tested and seemed to be working very well. It looks like the symbol table structure that I'm trying to build was actually being built correctly. And so today, the goal is to start working on the actual parser where the actual assembly will happen. And I have written a very short grammar of source files, and I've left out all the details because it's not so important. But we see here that a source file is 0 or more optionally labeled statements. This star here means that there's 0 or more of the things in front of it. So that means if there were 0 optionally labeled statements, then our source file would be an empty file, and an empty file is an acceptable source file. So 0 or more optionally labeled statements. Each optionally labeled statement has 0 or more labels followed by a statement. So it would be okay to have more than one label for a given statement. And then each statement is something that can it can be a string constant, which would produce object code. It can be an expression, which is an arithmetic or logical expression that produces a numeric value, which could be either 1 byte long or 2 bytes long. Or a statement could be a pseudo operation, for example, .bss or .text, .data, things like that. Or a statement can be a 6502 machine instruction. And although there's a lot of things here, that is, I mean to say, pseudo-ops could be lots of different things. There's lots of different machine instruction. These are the 4 basic type of statements that we have. And expressions have not only a value, but they can have a type, which might be reflected in the object code that's generated for them. But that's all details we don't need to worry about right now. Just so a source file is 0 or more optional labeled statements. An optionally labeled statement is 0 or more labels followed by a statement. And a statement is a string constant, an expression, a pseudo operation, or an instruction. Okay? So we need to write code that will look for statements and labels and things like that. All right? So let's go first to the AS0 file. What we have here is the actual main routine that opens the source file and does something with it and then closes it. Okay? And then it checks to see if there are more files, and if there are more files, it branches back up to main 0 up here, which opens the file and gets ready to read it. So basically, this part right here, scan and parse source file, is where this code needs to go that will look for statements. What we're currently doing is we print this JSR PR toke, which prints out all the tokens in the file, and then we JSR to dump, which dumps the symbol table. Both of those are going to go away. But I will, I think, leave that there for just a moment. And the whole PR toke, all of this code here should be removed. I don't want to throw it away completely yet, because if I do that and then I later find I need it again for some reason, that would be not so nice. So I'm not just going to delete it. In fact, I'm just going to move it to the file AS1. Okay, and I can just do that like this. Go down here and get all of this. These are part of it. These things here are part of that. So let's just put that out to some file. And yeah, now we will delete the lines. Okay, so all that's gone. And we'll load AS1. All right, AS1 is 60% full. I think we'll have room for this though here though. Oh, this is part of the dump subroutine. Now this dump also is something that is no longer really necessary. It's just debugging code, but we can leave it here for the time being. All right, and so let's bring in prtoke. And I think what I'll do is just to prove that everything still, I just want to prove everything still works first. So I'll make this an entry. Okay, save, and go back to AS0. And go ahead and get rid of, uncomment these lines. And just a symbol. Okay, yeah, we have some errors here. Which is, of course, related to the fact that we just move stuff around. Oh, of course, yeah, that's due to this whole code segment nonsense that that we have this end statement here that has to go away. Okay. All right, that looked good. So if I do that, yes, I get the same output I had last time. I need to go back and remove this malloc thing here. I don't need to print that out every time. So anyway, this is dumping all the tokens, and here's the symbol table printed out as we had before. Okay, so that all looks good. And right. Here is that debugging code that prints out the address that we malloced. We'll get rid of that. Yeah, that would just be deleted. All right, now we're ready to get in here and not do this, but instead start to look for statements. All right, we will need a variable. If you saw the most recent episode, you remember I talked about the special symbol called dot. And what dot is the location counter that counts out how many bytes of object code have been emitted so far during the assembly. You can think of it as the address at which the assembled code will be, assuming that you assembled it to start at code at location 0. And actually, in my assembler, I will have separate segments, a text segment, a data segment, a BSS segment, and those will each have their own location counters. But for now, I'm going to have one location counter. For now, I'm not going to have separate segments. I'm just going to have one segment for everything, which you could think of as the text segment. And the reason for this is so that I can do things in a simpler way, so that I can, as quickly as possible, have a functional assembler that I can use then when continuing its development. I can assemble the assembler with itself and then continuous development. So for the time being, it is not going to be separate text, data, and BSS segments. There'll be one giant segment which will have one location counter or one dot variable. So what I need to do is I need to make that dot variable, and it won't hurt to put it here. These things, of course, maybe in the future I'll organize it in a better way and put my variables in different places. But for the data segment will allow me to do that later anyway. I just put everything in the data segment, and they will automatically all get moved somewhere else. That's why I will have a data segment. But for now, it doesn't matter. I'll just put it right here. So I'll call it dot, and it's a 2-byte variable. All right, so 2 bytes. So what I will have to do here, I went up too far. Here we go. Is I want to initialize that variable to 0 at the beginning of actually, that's a good point. I don't want to initialize it to 0 at the beginning of each source file. I want to initialize that to 0 at the beginning of all the source files, because the way this is going to work is that all of the source files that are specified will be treated as one giant source file. They'll all just be concatenated together. So actually, the initialization, they won't literally be concatenated together, but they will be treated as if they were. So actually, I need to initialize it up here. Do I happen to have some place where I have a 0? No. Okay, no big deal. This is the loop where it opens a file. This is the top of that loop. So what I want to do here maybe here is a good place, right before I get the command line. Yeah, this is actually a 0 right here. That's guaranteed to be a 0. But I'll just do it like this. Okay, so I've initialized the location counter called dot. And now, when we have a grammar like this, we can kind of treat these as subroutines. So a source file is 0 or more optionally labeled statements. So what I can do is I can JSR to a subroutine which will look for optionally labeled statements. And I guess I can call that, what can I call it? I don't want to call it statement, because that will be a different subroutine right here. I'll call it lab statement. Now, of course, it's not really labeled, it's optionally labeled, but I'll just call it that anyway, because I'm devoid of imagination. All right, so what this means is it will look for a labeled statement and do whatever it has to do for that labeled statement. And when that labeled statement subroutine returns, it will give some indication of what happened. In particular, we want to know if there was an end of file. So I'm just thinking, probably we can set a, like set or clear the carry flag based on whether or not there was end of file. Something like that would be okay. So we can say maybe if the carry flag is set, then there's some sort of error that means that we cannot process this file anymore, or that it's the end of the file. So we can say BCC, that is, say if the carry is clear, to not main2. I'm just going to make sure there's no other. Okay, good. So in other words, we're just in a tight loop here. Go get a labeled statement and do whatever you have to do for it. And if carry is not clear, go to main2, and main2 just gets another statement. And if we get to the end of the file, then the carry will be set. So it will drop down here and close the file and so on. Okay. Let's see. More. I just want to go up here for a second and see f1, main0, main1, main2. More, okay. Whoops, didn't mean to do that. Meant to do that. So it looks like we don't need this label after all. That's what I was just checking for. Okay, so we just need to make this subroutine called lab statement. And how about that is EOF? Is that used? Nope. So we can get rid of that too. Okay, that all looks fine. So save that, load a new file, AS1. And the only reason we are loading this one up is because we need to go ahead to the next source file, which will be AS2. This one here is 70% used, so I'm not going to add anything else in there. But I am going to go back and look here to see, okay, so just append AS1 like that is how we do it. Oh yeah, that's right. I need to go to AS1. Go down here. Oh, I see it does append AS9. Okay, so we'll just make that append AS2. Save that. New file. And well, here do append AS9. Why did it jump so far? Append, well, whatever. Append AS9. And here we will have our new routine labeled statement. Okay, and I'll put an RTS there. And save to a new name, AS2. Just see if we can assemble the whole thing. It looks good. I'm going to dump that to the printer just to make sure. Okay, it all looks nice. Good. And now we're ready to begin work in our new source file. Okay, I just want to check something real quick. Which is just to make sure these things are available to us. And I'm thinking they are. Where is this thing? There it is. Oh yeah, so token value is an entry. So it's available to us. Okay, so good. And the routine is called scan, isn't it? See, that's the problem. I haven't actually written the code that calls this for a while, so now I don't remember. All right, PR here. Yes, scan. All right. Right, and we have all those token names that I probably also can't remember. All right, well, anyway. So a labeled statement has an optional label, well, 0 or more optional labels, and a statement. So what we're going to do here is first, we can, well, I'll go ahead and make it a subroutine. It might end up being so inconsequential that I'll just do the code inline, but JSR label. Okay, and then in this case, I would want to see, did I get a label? Actually, I think I'll just go ahead and, I won't do that. I'll just go ahead and call the scanner. So what a label is going to be some name, like my label, followed by a colon, or we have the possibility of numeric labels, which we haven't done much work on yet, which would be some number between 0 and 9, like that, followed by a colon. Okay, so these are the possibilities we have as far as a label goes. So to look for a label, what we'll do is we'll say JSR scan, and we will compare the result of the scan, the token that we got, with these possibilities. So if it's a name, then I can go to some place, and if it is a number, which I believe is tnum, then for now, let's just go to that place. And if it is an end of file, right? If it is an end of file, actually, yeah, not quite yet. Another possibility, it is an end of statement. Now, I'm not really sure if I still have that TEOS token. An end of statement is either a new line is an end of statement, or a comma. And let me go look. I think I want to check whether I still have this end of statement. Okay, there it is in this list of equates. All right, and we all return end of statement if it's an end of line. Okay, that's fine. Okay. So yes, if we get a new line character, it will return an end of statement. All right, and I'll just go here this will probably change, but I'll just go there if it's an end of statement. And if it's a comma, that also counts as an end of statement. So it would go to the same place. All right, and now we have to see if it's end of file. If it's end of file, well, if it's not an end of file, so it's not a name, it's not a number, it's not an end of statement, that is a new line or a comma, and if it is not an end of file, so if it is an end of file, I'll go here, just a new place. If it's neither of these, if it's none of these things, then what we need to do is we need to unget the token. Okay. So I will have a routine called unscan. And that will just basically unget the token, which the value is stored in A. And then I will, that means, so if it's not a name, it's not a number, it's not an end of statement, it's not an end of file, then that means we're in a situation where we don't have a label here. So we need to just get a statement. And in fact, I think I can just, at this point, jump to statement. So there's no labels, it's not the end of file, it's not the end of line, that sort of thing. We jump to statement. Okay? And now, let's look at what happens if there's an end of file. If there's an end of file, we set the carry and return. Setting the carrier indicates end of file. All right, that was lab statement 3. If it is an end of statement, like a new line or a comma, then we just consume that. That is to say, we got a comma or a new line. We say, okay, that's nice. Now it's time. I guess, yeah, we could just return with carry clear. Because it's not EOF. That's why carry's clear. Okay, I mean, I was thinking we could just jump back up to here and get another statement, which is certainly possible. That would mean that this subroutine would actually just basically read all the statements in the file, which is, I guess, doable, but we already just wrote a loop that basically calls this over and over and over again for each statement. So I think I'll just say, if you get an end of statement, which is a new line or a comma, that's fine. We'll just return. And let the loop be done out in the main routine. Okay. And now let's do lab statement 1. And this is the case that we got a number. And what we want to do here is just see if this number is followed by a colon. If it's followed by a colon, then it would be like this here. It's possibly a numeric label. If it's not followed by a colon, then it's not part of it, and it's not a numeric label. In fact, it's going to be an expression of some sort. So what we'll do is we'll, okay, yeah, we can't let this number be lost. We have to remember this number. That's very important. We need to look for the next token to see if it's a colon, but at the same time, we cannot lose that number. We have to remember it. I'm just thinking you could work in the scanner so that a number immediately followed by a colon is recognized as a numerical label and returned as a token numeric label. But I think I don't want to do that. If we did that, that would mean probably that you couldn't have something like this. And I don't really need to allow spaces after this, but it's just I guess it's a matter of just, it doesn't matter that much. It's a matter of taste. I think I'll just take care of it here, rather than go back and make it a scanner issue. So what we'll do here is we need to remember that number. So that means we need to get the token value, which is the value of the number. Well, there's also the issue that this numeric label has to have a colon after it, but it also has to be a number between 0 and 9. It can't be a negative, negative numbers are not handled in the scanner. It can't be a number larger than 9. It can't be 10, 11, 12, or anything like that. So the first thing we could do is just check and make sure. If the high byte is non-zero, then it's definitely not a numeric label. So I can go to a new label here. And what we'll do here is we're saying, okay, it's definitely not a numeric label because the high byte of the token value is not 0. That means it's a number greater than 255. So what we'll do is we will unscan and jump to statement. Okay, so we see a number is not a numerical label. We just unscan the number and jump to statement. Okay, and now we need to go ahead and check the low byte of the token value. And if it is 10 or greater, then also it cannot possibly be a numeric label. So we're going to unscan it and then treat it as a part of an expression. Okay, and so I'm going to store that somewhere and call the scanner. Let's see, so if this is not a colon, now actually we have a little problem. If this is not a colon, we've already have a number, and now we see it's not a colon. We have a number which is between 0 and 10, which is not followed by a colon. That means it's part of the expression. So actually, whatever this token is we just got has to be unscanned, plus the number itself has to be unscanned. And that implies a stack of unscanned stuff, and I really don't want that. I mean, it's possible, but I don't really see a need for that. Which makes me again think, okay, probably we should just have the scanner look for these things. So either we're going to have the same problem with the regular labels, the things like this here too, because we'll see it and we'll say, okay, I have a name, and names often have a value. So it's probably part of an expression. So we need to check though first to see if it has a colon after it. If it has a colon after it, then it is a label instead. So we'll have to remember the name somewhere and then look for a token. If it's not a colon, we'll have to put back both of those things, unscan both of them because it's now an expression, right? Just in case you don't know what I'm blabbing about, imagine I had a thing like this: myval plus 2. Right? This is an expression, and as long as myval has been assigned a value somewhere, then what will happen is that 2 will be added to this value, and then that number, whatever it is, will be inserted into the object code. But when I scan this, when I'm trying to parse, I'll read myval and I'll say, okay, I got a name. Now I need to look and see if I have a colon to see if it's a label, and I'll say, oh, I didn't have a colon, I have a plus. But now in order to parse this expression, I have to put the plus back and I have to put the name back. So I'm thinking I probably need to do this in a different way. I mean, I could do it. I just have to be able to push back more than one token at a time. That's certainly possible. Not even all that difficult. Or, optionally, I can go to the scanner and say, if the scanner recognizes a name and it looks for that next character, if that next character is a colon, I just say it's a label. That means labels will always have to look like this, my label with a colon immediately afterwards. You couldn't go like this, for example. But that's not exactly a disaster or anything. And also numeric labels could be the same thing. You couldn't have like, there has to be a colon directly after it. Yeah. So you guys can see by watching this or paying attention to it or not, that it's not like I thought all of this out ahead of time, because if I had, I wouldn't be doing this stuff and changing my mind in the middle of everything. Okay, so instead what I'm going to have, I think I'll go and do that in the scanner. Whoops. So what I'll have here is not looking for a name, but rather looking for label. Okay, and if it's a label, I'll go to label statement 0. And then not looking for a number, but looking for an in-lab, a numeric label, and that'll go there. All right, end of statement goes to lab statement 2, comma, which is another type of end of statement, goes to lab statement 2. End of file goes to lab statement 3. Otherwise, I unscan the single token that I have gotten, and I jump to get a statement. Okay. So now lab statement 1 is the numeric label place. And instead of all this, which I don't need now, and I guess I don't need this too. When I get a numeric label, well, I haven't implemented numeric labels in the scanner yet, or the symbol table has to hold numeric labels as well, and I haven't done that yet. So if it's going to have some sort of pointer to the label, and I guess that will be in Tocqueville. That makes sense. And that will certainly be the case for the regular named labels, that we're going to have a pointer to the symbol table entry in Tocqueville. That's the stuff we worked on before. Okay, so, and you'll soon see that numeric labels have a completely different sort of symbols table entry. So this pointer that I have in Tocqueville will be a pointer directly to the 2 bytes of memory that store the value of the numeric label. So all I have to do is take the current location counter and store that there. And I think what I'll do for that is I will get what's in Tocqueville. This is an address, or at least it's supposed to be. I haven't written the code yet that handles numeric labels. And store this Okay, so load a load x with a 1. No, load it with dot. Dot comma x. And store that in x, decrement x, and branch if not negative. Okay, this is a little bit ugly. Okay, so I'm taking this pointer I have to the place where the location counter needs to be stored. And I'm putting that here. Then I load x with 1, and I get the high byte of dot because x is 1, and store it in that place. Decrement x, as long as x is not negative, I go back up here. So now x is 0, and gets the low byte of dot and stores it in the low byte of that 2 byte space. Decrement x to -1, and now it doesn't branch up again. And this pointer, which is getting stuck here, which is originally in Tocqueville, is a pointer to the what we could call the symbol table entry for the numeric label. But if you remember, the symbol table entries for the regular names are 15 bytes long and include the text of the name and a type and a 2-byte value. The symbol table entries for the numeric labels include only a 2-byte value. That's it, nothing else. And so this pointer in Tocqueville is a pointer to that 2-byte value. And so we're using that pointer, we're putting it here, and we're copying the value of dot, which is our 2-byte location counter, into that place. Why? Well, because when we have a numeric label, for example, like this, okay, the location counter at this point is basically the address of this instruction, right? And so we want the value of this label to be the address of this instruction. So we copy the location counter into the 2-byte value, which has the address, which stores the address of this, which stores the value of this label. We copy the location counter into the value of this label here, so that whenever we refer to the label, we get back the address of this instruction, which is the goal. Okay? And I did here using this self-modifying code approach where we update this address here to be whatever was in Tocqueville and then copy the 2 bytes in there, right? It actually, again, might be simpler to use, or at least use a 0 page pointer, but then I would save the pointer and restore the pointer. I don't want to bother with that, so I'll just do it this way. That looks good. Now, after we've saved that, this thing, we're done with that label, and we might have another label, right? Because we have 0 or more labels. So at that point, we have to go back up here, just branch back up to the beginning. All right, so we copied the thing in there. As long as x is not negative, we keep copying, which is only 2 bytes. When x is negative, we're done, so we go up here. All right, and now we have the case of that regular named label, the label which is a name. And this is going to be very, very similar, but not exactly the same. The reason for that is that in this case, the value of our Tocqueville variable is not a pointer directly to the 2 bytes in which we need to store the location counter. It's the same thing. We're going to store the location counter, the value, the current value of the location counter in the symbol table as the value of this label. Right? It's the same thing like here we go. Here we have our named label, named foo, and in the symbol, and that will be entered in the symbol table. But the pointer in Tocqueville is going to be the pointer to the beginning of the entry, right? And we have to offset 13 bytes from that, 12 bytes for the name and 1 byte for the type to get to the address of where the value of this label should go. And the value of this label is going to be the location counter again, basically the address of this instruction. Okay, so we're just going to basically do the same stuff here. Although now I'm thinking maybe I want to use the 0 page pointer instead. So if I did use the 0 page pointer, what would it look like? Well, we would have to load these things from the Tocqueville and store them in the 0 page pointer. And then we could load, then we would have to load y with 0. We load this. I'm sorry, not that. Load dot. Or actually, we would do it the same way we did before. Dot y, decrement y. If it's not negative, then go up here. Like there. Okay, so is that really any better than this one here? I mean, it's a few fewer instructions, but not that big. I think just, I'm not going to bother with that right now. We'll just do it the same way. right? I'm just copying the code from up there. And again, if we get a named label, oh, of course I screwed this up. Yeah, okay. So I screwed this up because this has to be offset by, we have to add an offset of 13 bytes to this, which, of course, the easiest way to do it is make that 14, and then make this dot minus 13. So it's taking dot minus 13 plus 14, which is dot plus 1, and then it's storing it into the symbol table entry plus 14, and then decrement x, but then we would have to compare x against 12 here. So adding another instruction. I mean, there's really no reason for me to think about this and say, oh, can I save an instruction? It's just not really worth it. It doesn't matter. You know, one instruction is not going to, or two instructions or three instructions is not going to make a big difference. It's not going to change anything, really. You know, oh, my code is 10 bytes longer than it could be, or it executes and it needs an extra 30 microseconds or whatever. It just doesn't matter. All right, so okay, so no, actually, we don't want to quite do this yet. We also have to do one other thing here. Now that we have this label, we have a value for it, it's no longer an undefined symbol. It's a defined symbol. It has a type. The type 0, which is what it starts out as because everything is zeroed out in the symbol table. All the symbol table entries, when they're allocated by malloc, they're zeroed, they're cleared. So the type starts out as 0, which means undefined symbol. But now we're defining the symbol by assigning it a value. So we cannot have anymore the type stay as 0 or undefined. So we have to do something there. It's nice that this thing here is pointing at the right thing, but now we need this pointer again. And now I'm going to go back and do what I was debating in my head and talking about. I'm going to just go ahead and use the 0 page pointer. So up we go. And that's going to change something here. In particular, right? So this is just, you know, by this time, maybe you know the drill. Get the current contents of the 0 page locations, push them on the stack so that we don't destroy anyone else's 0 page data. And, but see, this is where we're going to want to come. We're going to loop here. So I'll make this the top of the loop. And now at this point, we need to restore these 0 page locations. So I'm going to put it in here twice for now, but I don't think I'll actually leave it that way. but just for the next 5 minutes or so, 5 or 10 minutes, it'll stay like that. Okay, so we save the 0 page locations. We start our loop. Okay, and now, instead of this here, this is the case of the numeric label. Okay, we put that in the 0 page location. Now, I was just thinking you could actually do that up here. You could like always put it there, but nah, just like this. Put it there in this case, okay? Now, it's just, I actually just wrote this code, didn't I? And then I deleted it. So let's do it again. All right, decrement y. Okay, load with 1, get the value of dot, store it in the space for the numeric label. Decrement y, as long as y is not minus, go back up here. And when y is minus, go to lab statement 9. That's the top of the loop up here, the new top of the loop right here. Okay, because we got one numeric label, but there could be another. All right, we'll get rid of this. All right, now this is just the same code, really. Only in this time we want to put 14 in y, 14 in y just the same way we have here. All right. And now load dot minus 13 y. So that'll give us the high byte of the dot variable and store that into here. Okay, decrement y. We still have to make this comparison for 12. If it's not equal, go to lab statement 5. All right, so the offset into the symbol table entry itself is 14. So we put a 14 in y. Dot minus 13 plus 14 is dot plus 1. So we'll get, that's the high byte of the location counter, stored into 14 bytes from the beginning of the symbol table. Right? Remember, each symbol table, I'm not beginning the symbol table entry. Each symbol table entry is 15 bytes long. So the offset plus 14 is the last byte of the symbol table entry, which is the high byte of the value of the symbol. Decrement y, 13 is wrong. Is it 12? If it's, so it's 13 now. It's not 12. We go back up here. Dot minus 13 plus 13 is 0. So we get the low byte of dot. Store that in offset 13, which is the low byte of the value of the symbol. Decrement y to 12. Now y is 12. So we don't branch. But what we do is delete this stuff. All right, and now we have y with 12 in it, which is nice because we want to put something in the type field. And that's kind of why I went back and used the 0 page pointer, so I can just do this very easily now. And what I'm going to do is put a 1 in there. Okay, I'm going to put a 1 in there. And what 1 ultimately will mean is that kind of long term is that it is a text. It is an add of relative location in the text segment. That is, it is a location of some code or a location of some data in the text segment. Right. And for now, the important part is it's not 0, because 0 is not defined. 0 means undefined. So our type, so we have now our symbol has a name. It has a value, which is the current value of the location counter, which is in the variable called dot right here. And it has a type. The type is 1, which means currently it means defined. In the future, it will probably mean relative location in the text segment. 2 will be relative location in the data segment. 3 will be relative location in the BSS segment. And then 4 will mean an absolute value. That is a value that's not relative. It's always the same. But labels are relative values, because if you move the code, the address of the value of the label will change. Whereas like a number, right? If I have something like this, which I can have in my code, like 23, this isn't. I'm now assigning the value 23 to the symbol foo as an absolute number. This number won't change even if I move the code around. So we have the possibility of text segment relative, data segment relative, BSS segment relative, absolute, and we also have undefined. So that's 0, 1, 2, 3, 4. We also have the possibility of it being an external symbol. It is a symbol which either we are defining in this file, but which can be seen, should be able to be seen by external files like through the linker, or it can be a symbol which is not defined in this file, an external undefined symbol, but which we expect to be made available to us through the linker. And of course, all talk of linkers is future talk, because right now we are very far from having a linker that will work the way that I would like it to work. Right now, we're working on an assembler, and our assembler, for the time being, is absolute. There's no moving code around. There's no linking, any of that stuff. But this does remind me that we have a different kind of statement. So when I made my little grammar today, I screwed up in the sense that I did not include assignment statements as a possibility. So an assignment statement is another possibility. We'll just add that in there. Okay, so now anyway, we've stored the type there, and we can go back up to the top of the loop and look for more labels. And I can do this branch if not equal here because I just loaded a 1 in the accumulator. Therefore, the 0 flag is not set, and this will cause an unconditional branch up here. And I think that is within the range of the branch. Good. So that means this code is basically done, except for, and I just mentioned this, I think. I don't necessarily need to repeat this stuff here, right? So I could set the carry and then branch of carry is set to lab statement 6. Get rid of this. And there. So if it's an EOF, I set the carry and the branch here, in which I restore the zero place location return. If I got just an end of statement or a comma, then I clear the carry and restore the 0 page locations and return. Okay, that all looks nice. I don't actually have a return there. And good. So now what I actually have to do is I have to go back and change the scanner to recognize both named labels and numeric labels. And that means I have to actually implement the code that puts numeric labels in their own special little symbol table, which will be slightly complicated. I mean, not that big a deal, but slightly complicated. But I think what I'll do here is I'll save this. I'll go back to the scanner. Okay, and actually I need to, before I look for scan, I need to look for here, this list of stuff here. And we're gonna have to add these two things in that we need. TLAB, this is for named labels, and TNLAB, and this is for numeric labels. Okay. And okay, scanner. Now where's the part where we find a name? Here we go. Okay, so SC name, SC name, SC name. So here's where we get a name. So at this point, we got, what is the unget C? Oh, that's the first letter of the name. So we jump to get name. All right. So we're going to go to get name. And what we do here is we loop looking for these things which can be in a name. Right? And as long as they're a name, we accumulate that the text, the letters of that make up the name in our buffer. It says text buff X. That I have a equate for text buff being 200 because I should. You know, elsewhere I was just using the value 200 directly because it's always in the same place. Text buff. Oh, well, it's right in front of me. There it is. So yeah. All right, anyway, here we are. We accumulate it in our buffer, which is at location hex 200. And then once we're done, once we get something which is not a character that can be a name, not a letter, not a number, not an underscore, not a dot, we unget that character and we look it up in the symbol table and we look for it, see if it's a keyword, we look up in the symbol table and blah, 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 blah. What I want to do though, at this point, is slightly modify this. And my thought now is it legal or should it be legal to have a keyword, let's just say the opcode LDA, and use that as a label? Is that going to be allowed or not? And I'm thinking, I mean, it can be distinguished from an actual opcode or instruction because it has the colon after it. So why not allow it? I mean, sure, it's probably confusing for someone to use that way, but that's their problem. So that means I don't need to, I can go ahead and say if there's a colon after it, it's automatically a label. So that means that here, all right, here, at this point, when I come here, I get some character which is not a name character. So I can go ahead and see if this is a colon. All right. If it is a colon, then I don't need to unget it. I just need to go and return the fact. Well, first off, I need to enter it into the symbol table. And I need to return the fact that it is a label and not a name. So get name 891. Okay, I've got plenty of label. I can use get name 2, for example. Right? Yeah. Okay. So I can say if it is a colon, then I'm not going to unget it, and I'm not going to unget the colon, and I'm not going to check and see if it's a keyword, which is what I'm doing right here. Okay. Oh, here's where I'm putting, okay, I do need to put a 0 though at the end. That's kind of necessary. I need to null terminate the name. So I can't just branch directly to get name 2. Okay, well actually what I can do, however, is branch around the unget C. So this can be get name 2 like that. Not here. So if it's a colon, then I don't unget the character. I go ahead and 0 out the token value, put a null at the end of the text buffer. I look to see if it's a keyword. Yeah, but that's actually, I was going to allow keyword, things that look like keywords as labels. Of course, I could just say, no, I'm not going to allow that. Also, I need to have it to wait down here instead of saying, okay, it's let me think about this for a minute. Let me think about this for a minute. Okay. So how about if I could first off, maybe I could do it like this. Just use Y to clear that out. And I'm actually not really 100% certain that this needs to be cleared out, because is keyword will return something. Well, it can affect the low byte. Lookup definitely will change the value of tokeval. But actually, the real thing is to null terminate that thing. That's very important. And I can't do this with a store Y. That's not going to work. So instead, let's just push the value of A, which is the character that I just read, which is not a name character. It's not a letter or a number or an underscore or whatever. Okay, just push that. Now I will clear tokeval, I will get the X value, which is the offset into the buffer, the text buffer, and I will null terminate the string. Oops, sorry, not that, text buff. So null terminate the name that I just read from the text, from the source file. Okay, now I will retrieve that character and compare to a colon. If it is not a colon, I'm sorry, if it is a colon, I will go to the label getName2. All right. Otherwise, I will unget the thing which is not a named character and not a colon. And then I will call isKeyword. So this is if I don't have a colon. All right, I will unget it. I will call isKeyword, store the result of that into a toke file, which is either a 0 or it's some value which says what kind of keyword it is, what kind of instruction. And then I will see did isKeyword return a name. If it didn't return name, then we're done. It's a type of keyword. Otherwise, we have to look it up, and when because it's not a name. I mean, it's not a keyword. We have to look it up, and we return. Which lookup will add to the symbol table if it's not there already, and it will also store the address of the symbol table entry in the toke file variable, and that will return tname to say it's a name. But I just want to basically at this point, if we got a colon, I want to do the same thing. I want to look up the name, but I want to return tlab instead of tname. That's really what I want to do. Mm-hmm. So I could just duplicate these two lines here. Which is simple. Okay, so if it is a keyword, it ends up going down here and returning. If it's not a keyword, it looks it up as a symbol and returns as a name. This is where it comes if it was found to be a label. It's a name followed by a colon. It looks it up, which inserts the symbol in the table if it's not already there, and returns label though, not name, tlabel. The other thing I could do is just put tlab right here. And then go through. I think I like this for now. This is what I like. Yeah, true. I duplicate this, but it's just because I need to return here name and return here label. All right, and I don't want to unget this colon. I want it to, that would be bad. So if it's a colon, if the character after the name was a colon, then we go down here, look it up in the symbol table. It can't be a keyword at that point. It's a label, and return tlab. Okay, yeah, I'm good. That looks good. And I'm just going to assemble it just to make sure that I don't have any horrible errors. I do have errors. Oh, unscan statement dot and dot. Yeah, I don't have the dot. Yeah, I added that dot variable, but I added it in AS0, and it's not an entry point, so it needs to be entry point. The subroutine statement I haven't written yet, and the subroutine unscan I haven't written yet. So let's fix those 3 small problems before this episode or installment is finished. Okay, and this again is, as I said before, just about faking out the compiler, the assembler, make it an entry. Okay. And then load AS2. We have scan and unscan and statement. Okay, so here's statement. Save that. And back to AS0. Here we go. And here's the part I said, return ungot token. So basically I need this. I need to have a variable that holds the token I'm going to put back. All right, and I think similar, for the unget character, I had a thing called peak C, peak character. So this would be peak toke. And that's 1 byte. And then peak val, 2 bytes. And unscan has to be entry. And it will do is, what it will do is simply store A in peak toke. And it will store toke val in peak val. And maybe peak val and peak toke are not really so well named, because they're not really about peaking at the token value, but more about peak implies a look ahead. We're going to look ahead before we actually get the token. We're going to see what token is coming next. I mean, you can use it that way. And anyway, we'll just put that in there and then return. You could use that way. For example, you could say JSR scan and then immediately JSR unscan. And then, but you can still look and see, right? You could look in peak token, peak value to see now what is that token that I just peaked at. By doing a scan immediately followed by an unscan, I'm peeking ahead at the token, but without actually consuming it. But anyway, it doesn't matter. Okay, store A and peak toke, toke val, peak val, toke. Okay, that all looks nice. And now what I do here is I say load peak toke. If it is equal to 0, go to scan 0. So in other words, if there's no token has been put back here, this will be 0. Like when this is all 0, initialized to 0, so when the very first time I call scan, it'll look here, it'll say, oh, it's a 0. So just go to here and act as usual. All right, if peak toke is not 0, then what I'm going to do is I'm going to move the value of peak val to toke val. Let me just do that with a different register. I can do it like this. Not that it matters. Just to use use all the registers just for no reason. Anyway, I have to do all this. Now I have to clear the value of peak toke. That's critically important. So by clearing the value of peak toke, then next time when we call scan again, it will say, okay, there's nothing there. No token has been ungotten. And I can return. All right, so if this starts out at 0, so if I call scan, never having unscanned anything, it will load peak toke. That'll be 0. So it will jump down here and get a token from the input file like it's been doing before. If I unscan something, when I unscan it, I have the token in A and the token values in toke val. So it'll store the token in here, peak toke. It'll store the token val in peak val, and then return. And if I then scan, it'll load peak toke, and it'll say, aha, it's not 0. So I'll copy peak val into toke val. Whoop, this is wrong. Copy peak val into toke val, like put back what was there before. And now clear peak toke so that we say, okay, we've used that up. There's nothing there anymore. And then return. Okay, so that's our unscan. It allows us one token of look ahead in the parser, and that should be everything we need. Okay. Assemble. Okay, no problems now. Assembly worked. All right, that's it. So next time, what we'll be doing is looking at those numerical labels, and I will show you how that works. And that is slightly complicated, but not that big a deal. So until then.